As I was saying, he is a DevSecOps and platform security engineer with expertise in secure software development lifecycle, cloud native security, and automation. He thrives in building scalable, secure systems, train teams on best practices, and drive continuous improvement across DevOps infrastructure and security workflows. Ayub, you can go ahead and share your screen.
Sure. Good evening, everyone. Welcome to today's session. Like I've been introduced, my name is Ayub. Someone just confirm that you can all hear me clearly, please. Okay, perfect. Like I was saying, my name is Ayub Mwangi. But you can call me Ayub Roti. I'm a DevSecOps engineer, application security engineer. Still a developer, very much interested in things to do with cloud native way of building applications, cloud native way of securing applications. I'm also into DevOps, DevSecOps, backend, just the whole mix. So in a nutshell, I'm an engineer and currently work with currently work at Cellulant as senior application security engineer, with my main focus being securing, the development lifecycle. Call it secure development. But then people do, call it DevSecOps. And for the sake of this session, we just call, that process of securing the SDLC, secure development lifecycle. We just, for purpose of this session, let's call it DevSecOps. So let me share my screen. So DevSecOps is this is literally an introduction. If you were to do the entire thing, this would essentially have a number of sections. There's an entire course on DevSecOps. But my plan today is to introduce it, spark a fire somewhere, maybe address and at least help you, do the groundbreaking, or just lay the foundations. And then probably, if possible, we can just have subsequent sessions where we dive into the nitty-gritties, of it. So I think we'll just go through the, outline the what DevSecOps is. Just do a simple demo, and then see how, talk about how, how it works in the actual world. If you are to do it in productions, in a production environment, not just as hobby, how do you do it? How do you measure success? What are you trying to achieve? So you can just be, if you do have questions, please put them within the chat. As the session goes, I'll be able to review them and I'll be able to review them. So You can see my screen. Just thumbs up.
Maybe enlarge it a bit.
Okay. No. Sorry.
A bit more. Yeah, I think that resolution is okay.
That's okay.
Yeah.
So what is DevSecOps? So DevSecOps comes from DevOps. And probably for those of us who don't know what DevOps is, DevOps basically, it's a culture of how you build applications. So traditionally, how applications were being built was in what people call, waterfall. So you'd have development teams who do their thing, who isolated. They go back and they isolated. They build their applications in isolation. And the old way of building applications, wasn't efficient. So along came with some development methodologies, talk of agile, talk of people starting to have use Scrum, and at the same time, technology was evolving. So initially, we would build applications as monoliths. Monoliths meaning if you have a big application with many components, you all bundle them up into one. But technology evolved, new technologies came up, cloud came up, with people got creative in how ways to build applications. And this new way of building application means that security also needs to be involved. So how traditionally, how was a security application security, how was it looking like? So what used to happen is that people used to wait until the end of development. So the developers would would write their code. Probably system admins would be the ones provisioning servers and helping developers to deploy the applications. And then it's only then that they would reach out to security. And tell security, we have this application that we've built. We want to roll it out. We're working with a deadline. Kindly look into it. So number one, security becomes, it's pushed to the end. As such, once you push security to the ends of your development lifecycle, because it takes a while to thoroughly test an application, security would become a blocker. Because you basically telling guys, no, before you go to production, before you deploy this application, before you deploy this API, before you push this mobile application, security needs to go through it, needs to review it to check for vulnerabilities. And right there, security becomes a blocker, since it's, that could take a day, could take, for you to do that work, that will take a day or two. And essentially, they become a blocker. And therefore, that is number one. Number two, that approach of security is very reactive. You wait until the end, and then you want to test and then suggest fixes. So in the real world, you'll find that deadlines are tight. Guys are working with very tight deadlines. and there won't be time to, this is the reality of it, there won't be time to fix issues, so developers will go ahead and deploy the applications to production, even without security giving a thumbs up, giving an all good that the application is good to go. So more often than not, this application will have vulnerabilities because no one has looked to no one has looked into them, and the application haven't been built with with secure defaults, with defense in depth in mind, and etc. So inevitably, this application will have vulnerabilities. So number one, it becomes very expensive and very costly in terms of revenue, in terms of even in terms of experience, user experience, developer experience, to fix vulnerabilities once they are running in production. So to solve this came the concept of shift left. And this is what DevSecOps is all about. That it's about putting security in DevOps and injecting security early into the software writing and testing. And that's what we'll be slowly breaking down. So DevSecOps integrates development, security, and operations, into one. And the main aim of this is, first of all, to make security automated, right? So again, security checks, if all security checks are done manual, that will take forever. That will take a long time, and that will affect how efficient your team is, in shipping your changes to production. So one of the key hallmarks or characteristics of DevSecOps, first of all, is automation. I mean, DevOps is also about automation. I mean, with DevOps, you're automating the way you test, the way you deploy, and automating aspects of operations. And it's that, and security also rides on that. That security also, if you have to do it within the DevOps environment, just to be automated as well. So that, me as a security engineer, I'm not a blocker. It has to be continuous. Why? Because developers push changes every now and then. So it has to be a continuous process. Does it, so meaning you're not doing it once, and that's it. And also, DevOps being about collaboration makes also, that means by extension that security now becomes a collaboration. It's a collaboration between who? First of all, DevOps itself, it's not a technology. It's a shift in a mindset, and therefore it's security. So with security, what we are trying to do is we want security to be everybody's business. We don't want to to retrofit security towards the end. So the goal is to build an environment, is to build mechanisms that enable detecting of vulnerabilities early. So you basically want to empower the people who are writing software, the people who are building your code, to have a security mindset, right? So it's about, I'm sure, most of us have gone into those InfoSec trainings where we say, security is everybody's business. The same thing here, the same concept here, we extend it to developers. That we want developers to write safer codes, and we want the guys who are deploying this code to deploy it in a secure manner. And at the same time, we want the security engineers not to be blockers, to come and automate their testing. So it is therefore, a shift from, we want to be more proactive. We want to move away from being reactive in the sense that, we only detect vulnerabilities towards the end, and we only detect vulnerabilities probably when they are already in production. And like I mentioned, that becomes very expensive to patch. That becomes very expensive to address, because there could be downtime that is associated with it. There could be loss of trust, leakage of sensitive data, etc. So just to recap this, is that the traditional approaches, you wait, pen testers come towards the end of development. But now with DevSecOps, we want to introduce mechanisms. We want to add capabilities within the pipeline in automated way to detect some of these vulnerabilities. That said, automation, there are things that you can never do. There are kind of security checks that you can never do with automation. So the goal is not to, entirely remove the human from the loop, but it's also to automate what is automatable, right? So for instance, if let's say your developers are building an application, it have thousands of lines, well, you could choose to go line by line and check whether you do have some injections, vulnerability somewhere, whether exceptions are being handled the correct way, whether they are logging sensitive data, right? So you could do that manually, but we want to leverage technologies out here that that automate this process. So how does this journey look like? So I don't know when I've talked about shifting left, and this diagram here is what captures that concept of shifting left. So I'll go through the developer journey, from the time a developer is writing their code to the point of where this code is being developed. So the recommended way, first of all, is in your initial planning phase. It is recommended to have security in mind. So one of the issues that we do see is you have product people, they come with a very innovative solution that addresses a certain niche, and they are seeing how they can make a product that generates revenue, that generates money. And that's what they will do. They will go to developers and tell them, this is what we're looking at. So how can we achieve this? So most organizations within that table, where you have people who talk product and you have people who now write code, security is never within that table. So for the security guys, I'm sure most of us are security. In one way, you're interested in security. You need to push that anytime there's conversation. So anytime there's that conversation, you need to be brought into that table, and bring in the security agenda. And within this planning phase, it starts with looking at threat modeling. Threat modeling of an application is looking into attack vectors, possible way to attack your applications, and what are the countermeasures that we will put in place. So threat modeling is a whole topic of its own that would take a whole hour or so just to address it. And once you've planned around, you've come up with your requirements, you have your functional requirements, you've identified your non-functional requirements, you've basically come up with, you've drawn us those diagrams, you've done the justifications. That's the planning bit. And then it will be now upon developers to start, to start writing code. I mean, like I said, we need to shift security to left. So that means the moment the developers start writing the code, I need to introduce security. I need to catch bugs. I need to catch, linting issues. I need also to catch moments where security I need to catch misconfigurations. Sorry. So how do you do this? So there are a number of issues that biggest that we do see. Number one, you're writing an application. This application connects to a DB somewhere. That means you will need a password, right? You don't just leave a database open to the world. Yeah, it could be within an internal network, but just leaving it that way, that's a security issue in its own. So there are passwords, there are credentials somewhere. So yeah, you can hear me. Just give me a thumbs up if you can hear me. So can you hear me?
Yes.
Okay, perfect. So someone had their hand raised, but if you do have questions, please just put them within the chat. Am I able to see the questions and comments? Okay. So I was saying about some of the issues with developers. Developers are not to be lazy. I've been a developer, so I'm just talking, the plain truth. They will cut corners. So now all things they do is, they will have passwords within the repositories, passwords to databases, to Redis, API keys, SSH keys, tokens, usernames, etc. So, and what happens is if those credentials are within the code base, they will commit that code base to to Git. And chances are some of the repositories will be public. So these credentials will end up being in GitHub, in GitLab, or whichever that you are using, and that risks exposure. So that is the first thing. So what does now mean for you as a security engineer is that you first of all need to make sure that this developer cannot be able to to code or basically move their code to this Git repository, GitHub, whichever, if they have credentials that are within, if they have hard-coded credentials. So, and that comes a concept of called pre-commit hooks. So, not here, but I'll just talk about it. It's one of the things you can do is, have pre-commit hooks. Pre-commit hooks is just before you commit, there are checks that are done. So you could do checks to do with for passwords. You're looking out for linting issues. You're looking out for code quality kind of checks, right? So developer at this point has committed their code, doesn't have passwords. But what if it does have passwords? So it is the purpose of this pre-commit hook, pre-commit hooks that you can set up using tools such as Gitlinks that will fail that process. At that point, what that means is that this code will never get into your repository, will never get to your GitHub, will never get into your GitLab at this point. So maybe this dev, if there are no passwords and secrets within the code, what's the next thing? The next thing is that we need to look at dependencies, right? So in the spirit of not doing what has already been done, developers will call a lot of third-party libraries. So you will, so let's say if you are writing, Python, for just an example, because I think that's the most popular language among a lot of folks, is that you will import libraries from, different places. So how do you make sure that the code that is outside your control doesn't ship with backdoors, doesn't come booby-trapped? Is that you will do software composition analysis. So with software composition analysis, you're basically analyzing these dependencies. So you can call it dependency scanning, dependency checking. So you want to check for dependencies. I mean, if you want to prevent supply chain attacks, that would be a good place to start with. And once you talk about supply chain attacks, a few years ago, they'll start, popular attack that happened. So you want to check your dependencies. Again, secret scanning, dependency scanning, you're doing it not physically, in an automated way. So now you've checked your dependencies. So if there's a dependency with a vulnerability, then that component has no business going to production. Yeah. So if let's say you're using, talk about Log4j. I'm just mentioning the, the things that probably everyone could relate with. So if you have vulnerable components, then they have no business being shipped to production. You've done your secret scanning. You've validated that this code doesn't have secrets, one, before the developer commits. Also, you could do it after the commits within the pipeline. You've looked at dependencies. Why? Because you don't want, to build. You don't want your final application, your final product to be vulnerable. To be vulnerable by design. And there comes now the other check, that is SAST. So SAST is static application security testing. So as the word suggests, SAST is a static check. So with SAST, you're looking for, some of the what do I call them? Whether now the developer is writing code with security in mind. So what would, SAST be looking for? Things such as input validation and injection vulnerabilities. If let's say you're using insecure functions, right? So for the guys who've used PHP, there's a dangerous function called eval. If let's say it's Python, probably they're using exec, and these are system commands, or even in Java, let's say there's that system command. These are functions if you're using as a dev, and probably you're not doing input sanitization, or I could end up running OS commands. Talk about OS injection. And also you could use SAS to look at some of configurations. I mean, so some people will write an application that has debug mode on. So I'm sure once you've ever loaded the application, you go to console and then you're seeing it, the browser console spewing all manner of debugging information, right? So whether this debugging is front-end or back-end, still an issue. That's just an example of things that you would be looking with SAST. So if let's say a developer has written a function, a library, a function that has issues, that doesn't have input validation, that has injection vulnerabilities, you can now introduce what is called security gates. Now with security gates is that you're coming up with a criteria that most of these tools like SameGrep, SonarCube, the most common tools for SAST, has its own mechanism of rating vulnerabilities in terms of severity. So you, as a security engineer, you could decide that, we are not allowing critical vulnerabilities, we are not allowing high risk vulnerabilities to be shipped to production. We not even some people will go further and do medium vulnerabilities. So that is as at the SAST level. Remember, these are static checks. And the other kind of check that you'll be looking at is ISC scanning. So infrastructure as code. This is also something that is quite broad. Again, as everything today can be provisioned with code. So even some people will go ahead and say everything as code. So you do have infrastructure as code. What we are saying here about introducing security, SAST, dependency checking, SAST. You could say that is security as code. They also even the concepts of, for those who do benchmarking, you can have policy as code. So ISC infrastructure as code has come to help development, the operations teams, or rather, let me just call them the DevOps team, to be able to automate provisioning of infrastructure, to automate things such as scaling. Basically, it solves the automation problem. So again, it's also code in itself. So also you need to, when I talk about ISC, I'm talking about the likes of Terraform. I'm talking about the likes of Ansible. So they also do come with a whole set of issues. You have misconfigurations. You also have hard-coded credentials. And when it comes to ISC, let's say if you're provisioning on, let's say, AWS, you're provisioning on most of the cloud providers, you start looking into IAM things, IAM issues. So it is also part of a static. It's also a kind of a SAST that needs to be done. So again, so you'll also have a job that does this, and then the next, what you'll be wanting to do is container security. So long gone are the days when you used to install applications on the server, on the bare metal server, right? Or even on an EC2. People still do, but it's generally not so common. So what happens is with advent of containerizations, people package their applications into containers. So what this looks like is you do have a base image, and then you have on this base image, you come and now build, you add another layer of the application, add a layer of the code that you've written. So, and then that's on top of it, that's now you build it, becomes a container. So in terms of deployment, you leverage technology such as, you could be using Docker Compose, you could use Kubernetes, you could use OpenShift. and many other orchestration, Docker Swarm, and many other forms of orchestration. So remember, so here we introduce another dependency, another external dependency, that is the base image. So this base image could also come with vulnerabilities. So basically what you want is that you need to be sure that this base image is not coming with vulnerabilities. You need to give that assurance that, yes, I've checked my code in terms of SaaS, in terms of secrets, in terms of ISE. Now you need also to be sure that this base image that you're building your business logic on doesn't have vulnerabilities, and that's where container scanning comes in. And with that, we have a tool such as Triv. And then towards at this point, by the time you're doing container scanning, you're already deploying. You've built the application, it's been packaged into a container, and it's being shipped to your orchestration technology of choice. And that's where after deployment, you can do dust. So typically Babsuit, the likes of Babsuit, the likes of WhatsApp, just talking about the common kinds of checks. It's where dust will be coming in. But if you'll hear people talk about advanced kind of dust, where you have API dust, you have interactive interactive application security testing, that is a more advanced kind of assessment. But at this point you've deployed, you also need to make sure you have your application is running, it's already up and running. You also need to make sure that vulnerabilities happen to to be released every day. So your application could be clean today, but tomorrow it's not. So how do you discover new vulnerabilities? And this is where the aspect of security being continuous comes in. That means you also need to have a mechanism to run these security tests for your applications during runtime in production. So that is also a kind of scanning and testing that's also something else that could be done. So something more advanced would be to talk about compliance, adding compliance checks to this pipeline. But I think that would be a bit more advanced for now. But it's something, that we could also look at some point. So DevSecOps at first seems to be, it seems to have a lot of moving parts, and that's where I'd like to, before I'll come in a question. This way I'd like just to talk about. I mean, what does it take to get you started? That means, first of all, you need to be able in a position to understand continuous integration frameworks, the CI frameworks, and even before understanding the framework, just understanding Git itself, right? So you also need to you need to understand Git itself. Sometime back, I did read an article. I did come across an article, where they were saying, security engineers, in the near future will be like developers. And, you'll be interacting, you'll be writing code, whether it's whether be it infrastructures code, code. In one way or another, you'll be writing code. So it comes by default that you need to understand Git really well, because if you're to if you are to incorporate these pre-commit hooks, if you are to add these scanning templates, if you are to add SAST, you all do it within within the repositories that sit within a Git repository somewhere. So understanding Git, that is number one. Number two, understanding these frameworks, GitHub Actions, GitLab CI, and Jenkins. So you would need to understand, you need to understand this. And another concept that probably you would also need to understand as part of, if you're to be a DevSecOps engineer, is orchestration. Know how to write Docker files, know how to do, minimal builds, know how to harden these Docker files, right? All right. So get to orchestration layer, understand Docker Swarm, understand Docker Compose, understand Kubernetes, basically orchestration in general, right? So that's what means that you also need to understand infrastructure as code. Meaning that you need to understand Ansible, you need to understand Terraform, the most popular, but that said, there are other infrastructure as code languages that you could look into. What else am I missing out on? Yeah, and basically understand the tooling. Be able to understand what the kind of tooling that is out there, that is needed out there, right? And being able to understand vulnerabilities, right? So basically, you don't have to be a good dev, but you at least need to understand, the journey that a developer, goes through. Because if you basically asking them to, that basically telling developers, guys, security is everybody's business. That means as well, you also need to understand the experience. Why? Because controls that you introduce into their life cycle shouldn't be a hindrance, shouldn't be a blocker, shouldn't as well slow down their productivity. So these scanners, the secret detection, the dependency checking, the container scanning, they take time, and that's the cost of adding security within your development. They take time. So, and therefore, that means that the moment you're introducing tools, you need to have their buy-in. So, and this is where the component of collaborations comes really important in terms of DevSecOps. I mean, DevSecOps is not just about technology, it's about collaboration, and it's about visibility. So developers will come and tell you, look, you said the tool complained, we have, there's a vulnerability. I have spent time trying to patch this vulnerability, trying to address these vulnerabilities. And that effort needs to be visible. So what that means is that security needs to be visible to all layers. Security issues need to be visible to developers, needs to be visible to their managers, and need to be visible to those people who concentrate with product, and need to be visible with, top level management, right? And that said, even the effort of addressing these vulnerabilities also needs to be visible. Needs to be visible to all these layers. And that also comes with, coming up with what is your success criteria. At what point do you say that, we've set up DevSecOps really well? But a good place to start would be to start with one tool. You just integrate one tool and make it perfect. If let's say you're doing secret detection, you start with secret detection. incorporate it fully within the development lifecycle, create visibility, have ways of tracking, being able to report on issues that are how many secrets have been detected, how many have been addressed. So if I'm to talk about secret detection and secret management, is a whole topic of its own. You can't have for instance, you can't require developers not to hard code credentials without you giving a solution, without giving a recommendation that fixes that problem. And therefore, that means, you as a DevSecOps engineer, your knowledge goes, you're also required to understand things such as secret management. You also need to understand, some other concepts such as GitOps. Why? As a DevSecOps engineer, you'll be working hand in hand with DevOps. So DevOps, they have their own technology stack. So it's upon you to just to sit down, analyze, whichever technology stack they are using, and see how you can, you can leverage them to just make this journey of onboarding security much, much, much easier. So that is the introduction. And I don't think we do have time for demo. So we'll probably plan for a session where we just try to build a sample pipeline, build security on top of it. That is more hands-on. So I do have it, just that this time is running short. And I'd like to just to respond to questions at this juncture if there are any. Please, guys, ask questions.
Ayub, can I ask a question?
Yes, please go ahead.
I have three. The very first one, you've said many a times developers use third-party code. This is so common. When I was a backend JS developer,
Yes.
many of the tools we have to install packages, and you say that it's very important as a security engineer to scan those libraries to see if they are safe for use. How about now the tools that we are using to scan those libraries? Are they safe because they are automated tools? You're not the one who developed them. So at what point are you satisfied to use a particular tool and not use any other tool? My second question is, you say that application security is a continuous process. You're supposed to be detecting new vulnerability. How do you able to do so? Especially if you're starting off, now that we have known vulnerabilities. For instance, if you go to OWASP top 10, they are the knowns, like broken object, the injections. How are you in a position to pick the new ones, especially if you are starting off? Now, my very last one on secret management and detection. You want to prevent hard-coded keys and secrets here.
Yes.
Many people and many developers use .mv file.
Yes.
Is it safe? Is it safe? Thank you.
All right. So let me start with the first question: is how do you make sure that these tools that you're using for security are not an issue in themselves? They're not basically backdoors into your ecosystem in themselves. In security, there is the concept of attestation. So, actually, if you go to say for instance, if you go to Docker Hub, you'll be able to look at attestation information. So attestation is that a process of verifying the integrity, the trustworthiness of system, of artifacts. So do not use tools that don't have this kind of information. And also, a good bet would be making sure that you first of all testing these tools and you verifying this attestation information about them. This attestation is comes in various formats. So you could look into the concept of supply chain attestations. So this is metadata that will tell you who built it, when was it built, and probably there could be some sort of signature. So attestation, you have supply chain attestation, even a platform, you have platform attestations, runtime attestation. So just that's to to answer that issue of attestation. So the second question was so what are so you asked about the ENV. So let me respond about the ENVs first. So in itself is not secure, right? Because ENV, that's Python, you have application.properties for Java. They are still, they're still at least it's better than hard coding in your code, because if you secure that the ENV, but it's not good. It's not enough. So why? This ENV at some point will be shipped to will be sitting in your repository. Why? You could say I've excluded it, but chances are eventually it will find its way into your code repository. So, and that's where the risk comes in. And that's where now the dependency of having a secret management technology in place. So you could look into the most common Vault. So for instance, how could you leverage Vault to stop using ENVs? So you'd have Vault, inject your secrets as environment variables. So the third one is how do you detect vulnerabilities that are already there, right? So let's say you've inherited an application.
No, that are new. Vulnerabilities that are new.
Okay.
That you've never encountered.
Okay. So one in when the application is in production, you could leverage technologies such as, just notice somewhere, such as New Vector. You could have a scanner such as Trivi. So we had Trivi doing the container scanning that was scanning within the pipeline. So it could run inside your orchestration environment, inside the environment where you're deploying your applications, to periodically scan your workloads in development. That is the first way. So I'm just using Trivi for simplicity purposes. But you could have full-blown technologies such as container protection, technologies such as New Vector. But for just, you could use Trivi to just do that, protect, scan, at least scan for vulnerabilities, for misconfiguration during runtime. The other way is that, remember, you're leveraging GitLab. So you could have workflows. You could have scanning policies that are periodic. So the modern day GitHub, I could talk about GitLab, just allows you to schedule scans. So that means that is, you could set a scan that's schedules your code as it sits within your repository every other week, every 2 weeks, monthly, and then it's reporting on vulnerabilities. Does that answer your question?
Very much, very much. Thank you so much.
All right. See, our time is very much spent. Yeah. So any I request that you
I
be
have a
allowed.
question.
Yes, please go ahead.
Yeah, so yeah, thank you first of all for the presentation. It was quite unique of demonstrating DevSecOps. Now, there is this post on LinkedIn that I'm sure you saw. So it was this guy who was just saying that instead of going for all these certifications, you should not. He listed some stuff that you can do, like getting course with Linux. I mean, he listed some stuff. So I just wanted to know if you have your own version, like your own tips for now from here, how we are going to put all this into practice so that at least we can succeed in this field of DevSecOps. Thank you.
Okay, yeah, I think I saw that is a post by a guy called Said, right? I think I saw that.
Yeah.
So yeah. So where he just had an elaborate list, just understand Linux, understand Git, understand cloud. It's very true. So and probably okay, yeah. So maybe I can just maybe just let me quickly go through what you're saying. Get comfortable with Linux, SSH, master Git, pick one cloud and go deep, be it Azure, AWS, GCP, learn infrastructure as code, understand YAML, build CI/CD pipelines, deploy something, think like an engineer, monitor everything, Prometheus, Grafana, that is the observability, automate. So whatever he's saying here is true. I do agree with it, but if you have the opportunity to look for cert, well and good. So what I don't like is personally what I do see guys who, are full of, you have so many certificates and you can't even build even a simple pipeline, that a simple DevSecOps pipeline. So definitely my take is to, build the skill and then seal it with a certification. So for me, my order is to actually implement real pipelines. If you can, seal it with a certification. I mean, it wouldn't hurt. But first of all, understand Linux, Git, understand some cloud, understand infrastructure as code, understand CI/CD pipelines. Yeah, if that answers your question.
Yes, it does. Thank you.
All right. Any other question?
I have a question. Am I audible?
Just speak up, please.
Okay, I've heard you speak.
Yep, you're not so audible, but yeah, just go ahead and ask.
Okay, I'm asking this way. What's the difference between GitHub and Git? This is me every time I come.
Difference between
Git and GitHub.
Between Git and GitHub?
Sure.
Okay. So Git is the so GitHub is a platform that uses Git as the engine, as the tool. So Git is it's a tool that is used to help with management of code, right? So, tracking, versioning, tracking changes. If let's say you want to revert to a certain version of your code, now that Git is a tool, and now GitHub is a platform that implements this Git and makes it offers that as a service. So does GitLab. So no, that would be a tool that would be essential to you as a person who is starting into DevSecOps, because the development, all code goes through Git. All infrastructure as code goes through Git. The automations for this tooling will be sitting in Git somewhere. So you really need to understand Git, the tool, and the platforms that implement this Git. I've just put it plainly and simple. So does DevSecOps sounds hard? Shouldn't scare you. The thing is to, it definitely requires you to have a number of skills, be able to understand, the developer journey, their toolings, be able to understand the toolings of your DevOps team. But as usual, start small, right? Start small. Start with one tool, one integration. Any other?
Okay.
Yeah, please go ahead.
Okay, my question is, are there maybe GitHub repositories or projects that one can undertake, or you can provide so that somebody can practice, for someone who wants to join DevOps can try to build their skill as they are to perfect their skill?
Yeah, I'm sure there should be. So let me, if you just go and Google DevOps for some reason. If you just go ahead and just Google, awesome DevOps list, so you will see. But then this will overwhelm you. That's the problem. Let me see. Let me see. Yeah. Just go to Google and go to just awesome-devops.xyz. Let me just visit the page here. Okay. So for the person who asked about DevOps, so this is humongous, and this would, if you take the approach of just reading and it could overwhelm you. So my recommendation would be this: take a simple script. Could be a Python script that is doing a hello world, right? So it's an application, you have an endpoint, be it Fast API, be it Flask, whichever, right? So write a Docker file for it so that you can learn how to write code, to build images. On top of that, add a simple orchestration. You could even start with GitHub, with Docker Compose. Put that code within GitHub, put it in GitLab. Now, just security job. So you could say, I want to do SAST, right? In GitHub, you can use GitHub workflows just to enable SameGraph, or you could use even GitLab just to enable SameGraph, and just see, try to implement that end to end, simple, and then you can scale up bit by bit. But yeah, so tools are there, repositories are there, but simple projects are there. But I think the best way to be, starting small. Maybe if allowed, we could have a session where we go into, a sample small application, so that those of us here who are interested could use it. All right, the last question before we come to a close. Any other?
Yeah, my question is, what do you advise in terms of version control between GitHub and Azure DevOps? Because currently many people are preferring Azure DevOps. What do you advise on that?
That is a matter of preference. I'll give a very generic answer. So I don't know. I have not per se haven't used Azure DevOps, right? Most of my implementations are, GitHub, GitLab, and basically a lot of other open source stack. But at the end of the day, you choose what works for you, and what makes your life easy. Because I think at this point, we seeing this tooling being standard, right? So regardless of you're using Azure DevOps, or regardless of whichever alternative you're using, the same tooling can be adapted to, the same. You will be able to still have SaaS. You'll be able to do your secret scanning. You'll be able to do your dependency checking, regardless of, your stack. So at the end of the day, you work with what works best for you.
Excuse me, Ayub, are we going to have this recording?
Yes, you can. I can last with the team to make it available.
Thank you.
All right. So hopefully we can. I'm looking forward to seeing you in a session where we've just done an introduction, an overview. It's a lot to swallow. It's a lot of content, many concepts, many different concepts to, for a person who is starting out. But I'd like now, we set up a simple end-to-end DevSecOps pipeline and see, and see what that looks like. Then if there isn't any other question, I think we can come to a close. Thank you very much, ladies and gentlemen, for availing yourselves. Bye.
Thanks, Ayub, for your time. Just before you leave, is it possible for you maybe to leave your contact, say your handle, so that people can follow you and even ask questions if they still have?
Yeah, sure. I think I'm quite responsive on LinkedIn. But if you do, so in LinkedIn, I might go by Ayub Roti. Ayub Roti. And if, let's say, you need to, have a very, something that you really want us to look into, you could reach me on 0727 517 942, 0727 517 942. Like we could talk about DevSecOps and security. Yeah. Then, yeah. So, but on LinkedIn, I'm Ayub Roti. But if you prefer to shoot me an email, you can do ayubroti@juaji.com. So feel free.
Ayub, do you have an X account?
Still Ayub Roti. Yes.
Okay, there you go. So we can call it a night. Have a nice evening, everyone. See you next week. Bye.